All right, so isosceles triangle theorem. It would help if I actually had my. So typically the basis of the isosceles triangle theorem is that you have two sides that are congruent, two angles that are congruent. And those sides and angles are opposite each other. That's how you can tell where they are. So how does it always do this? So if we look at the isosceles triangle theorem specifically, so right here, all right. Can everyone see that, or do I need to cut the light out? Do you guys want me to cut the light out? Okay. Lucas, you mind doing that light switch next to me, please? Thank you, sir. Other one. All right. Whoa, it's really dark in here. Okay. So again, with an isosceles triangle, it's all about the two congruent sides and the two congruent angles. That's how you know you have an isosceles. All right. Now, the two congruent sides themselves are called legs. Now, you may have seen this notation before, you may not have, but typically when we're talking about congruent sides, those are notated by these tick marks. And I like to say that these are like a matching game. So in other words, let's say I had a figure, all right, and it had these tick marks, all right. It's a matching game. So in other words, the ones that have the same number of tick marks are congruent. So these two sides would be congruent because they both have two tick marks. All right. Same thing over here. These two have only one tick mark each, and this one doesn't have a tick mark at all. So we have to assume that these two are congruent. Now, those are called the legs of the isosceles triangle. So similar to how if you have a right triangle, how you have the hypotenuse for the two legs, same concept. All right. Now, the base is the side that's not congruent. All right. Now, sometimes it is the actual bottom part of the triangle, but that's not always the case. So, for example, with this one, this is an isosceles triangle, but the base is right here. All right. Now, the congruent angles are opposite from the legs. So opposite just means directly across, diagonal. Another way I like to think about it is that it's the angle that is not formed by that specific side. All right, so in other words, remember an angle is two rays together. The congruent side would not be one of those rays. All right, so like for example, leg one, its opposite angle is right here. Because if you look, the two rays that form it is not including that leg. Same thing over here, leg two, that's the opposite angle. All right. Now, those two angles are also congruent. Those are called the face angles because typically the face is one of the rays that makes up. All right. Now, the last angle is the vertex angle, which is formed by the two legs. So the two legs are the two rays that form that angle. That's how you know it's the vertex angle. So both of those sides should be congruent to it. And it's also opposite the base. So basically, what I like to do sometimes is I just draw diagonal lines. It's like, okay, that would be the opposite angle here. That would be the opposite angle here. That would be the opposite angle here. All right. Now, knowing what opposite means will come really handy when we get to our trig lesson, like way down the line. So knowing that will come a lot in handy. And again, basically the isosceles triangle theorem is just saying if the adjacent sides of the triangle are congruent, meaning, remember, adjacent means right next to each other. They share a side, they share a vertex. But That's adjacent angles. The adjacent sides meaning they connect at a point. All right. Are congruent. That means the angles opposite them are also congruent. That's what I marked here. And then the corollary or the opposite of that is basically if you switch the order of the statement. So if the angles opposite, so if two angles opposite two sides are congruent, then those two sides opposite it are congruent. So in other words, opposite angles, so angles that are not next to each other. So like these two are opposite angles. All right. The triangle is congruent. The sides opposite them are also congruent. All right. So another thing to note is congruent angles, same concept as congruent sides with how they mark them, except they mark them like this. So the amount of like little tiny circle denotes congruency. So if you see, and again, it's another counting game. So notice how I made two circles on this angle. That's to denote that it's not congruent to these two, it's only on one. All right. So again, it's another counting game. Sometimes you'll see it with looking like this. If you see that, this one has 3, this one has 2, this one has 1, that means none of them are congruent to each other. All right. And again, knowing this notation is really important because this unit's all about congruent triangles. And when we get to the postulates for how you can tell whether two kinds of triangles are congruent or not, knowing this notation will help. All right. Does that kind of clear that up for my classes? Any other questions on any of it? So mid-segment theorem, you guys are pretty good on. Maybe go over anything else. Now for a little piece. Not necessarily, no. So today's lesson is all about parallel lines cut by a transversal. So it's really not much connection. All right, any other questions? So again, for whatever reason you could not watch the video, just watch it tonight. Not a big deal. I'll double check the links, but just use the one that's in the notes page, right? And I relinked everything on your homepage, so if you click like the button on the homepage, it'll go to the Unit 2 stuff, not the Unit 1 stuff. If it doesn't, let me know. I checked it on my end, but sometimes technology can be funky. All right. And yeah, guys, in the future, if that ever happens, feel free to shoot me an email because I'll change it. Because I make mistakes, especially when I'm in a haze of sickness. So please just shoot me an email because you guys know I do respond to emails fairly quickly. See them on my phone. So if you told me that, it would have been fixed like within an hour. Okay. Don't be scared. You ain't gonna hurt my feelings if you email me and be like, hey, you linked something wrong. Or you're like, oops a doodle. My bad. All right. So again, anything else on 2.1, 2.2? All right. So remember, there is a delta math for 2.1. I typically make my delta math due the next day by midnight. However, since I wasn't here, I'm going to make that due Friday by midnight just because I wanted to make sure if you guys had any questions, I could answer them. All right. There's also a 2.2 delta math that I just assigned today. It's mainly on factory review. I'm also going to make that Friday by midnight. Okay? Just so if you guys have questions still, come ask me. All right? Okay. So today we're starting 2.3, which is all about parallel lines and the angles formed by them when they're cut by a transversal. So go to page 12 in your packet. And I don't have my pen. Oh, also guys, watch the clock for me. We have to be downstairs for pictures at 9:05. Okay? So that clock says like around 9 for me. Alright? Because sometimes I'll get caught up in something and then y'all ain't get your pictures taken. So 9 o'clock, warn me, and we'll head down there. Alright? I'll try to keep an eye on it too, but no promises. So 9 o'clock. Alright, we gotta be down there by 9:05. Alright? So 9 o'clock. Alright. So like I said, today's all about parallel lines and transversals. So you may or may not be somewhat familiar with this. If not, that's okay. But what we're going to be talking about is all the different relationships that these 8 angles formed by these 2 parallel lines and cut by this transversal have with each other. All right. This will come really in handy when we get to our proof section of congruent triangles, as well as the proof part of parallel lines. All right. So this unit is very theorem heavy. All right. It's actually not a whole lot of quote unquote math in it per se. It's mostly theorems and being able to identify what theorems happen. All right. So instead of being a lot of calculating, it's more so can I identify what's going on and make a conclusion from it. All right. So let's just go ahead and get into the swing of it. So first things first, just a quick reminder, supplementary angles are 2 angles that add up to 180. They typically make a straight line. Another name for that, you may see it as linear pair, pretty much the same thing. All right. Now, before we even get into talking about the different theorems, we're going to talk about how to name our parallel lines and how to name the transversal. So first off, which 2 lines are my parallel lines? Right, M and N. So typically lines, if they're not line segments, so between 2 points, or there's not 2 points saying like, okay, line AB, they're usually denoted by a lowercase letter. All right. So these little lowercase letters are the line names. So if you want to highlight them, that's probably a good idea. These are all line names. Another way they could name the line is say if they had a point here, it's an AB. Could have said that's line AB. All right. But if they don't have those points, look for the little letters that make the line. So our 2 lines are line M, which we do the little lowercase letter with the line symbol across the top. So not just a straight line, put the arrows on it so we know it's a line, not a line segment. And line N. All right. Now, to actually state that they're parallel to each other, we write it like this. We say that line M is parallel, so we draw like what almost looks like an 11, but it's more like 2 straight lines next to it, to line N. So this symbol right here denotes that those 2 lines, line segments, whatever, are parallel. So in math, we hate having to write out as many words as possible, so we shorthand a lot of stuff. All right. There's so many math symbols, especially in geometry, to shorthand whole words. So, like for example, congruence. I talk about this in the videos, but congruence is typically the equal sign with a little squiggle on top. That means congruent. When we get to similarity, it's just like this little squiggle. There's a bunch of different symbols in math that denote whole words or whole concepts because math people are notoriously lazy and do not want to have to write out the full word. All right, especially when they're doing things like proofs, which again we'll get into later. All right. It's basically just shorthand. Now, if this is on a test and you told me that, like you actually wrote out line M is parallel to line N, would I take off points for it? No. But just make sure you recognize that this symbol means parallel. Okay. Now, to name the transversal, which by the way, a transversal, if we gave you a definition real quick, that is the line that intersects a set of parallel lines. All right. So the line that's going through those two parallel lines, what is that line? It's line P. Good. So our transversal line is just line P. So this is our transversal, and these two are our parallel lines. Now, something else to note is that sometimes they will flat out say M and N are parallel. Sometimes they may denote it using an arrow. All right. So arrows are another form of tick mark, so to speak, except this does not denote any type of congruency. It just denotes parallel. All right. So if you see two lines with the same number of arrow ticks, that means that they're parallel to each other. So that could be they have one tick, they both have two ticks, whatever. All right. So if you see those tick arrows, that just means parallel. All right. Now, before we go any further, I will say you may want to have one or two different colors with you. So highlighters, pens, if you need colors, there's some color pencils on the shelf. So take a minute, go grab what you need right now. I would say at max, you maybe want 4 colors. All right. The reason why is we're going to be color coding some stuff. All right. Everyone got what they need? All right. So now let's actually talk about the different types of angles you'll see when it's formed by two parallel lines cut by a transversal. All right. These are all the different theorems, so to speak. So with parallel lines cut by a transversal, there are two outcomes of what their relationship is. They're either going to be congruent or they're going to be supplementary. All right, those are the only two outcomes that come out of the different theorems. They're either going to be congruent or supplementary. So in other words, you have like a 50-50 shot of getting it right. All right. So first things first, we're going to name and highlight the vertical angles. So vertical angles, first off, we talked about this in 2.1. What is a vertical angle? How do I know if two angles are vertical to each other? You can look back at me too. Say that one more time. They're diagonal from each other. That's part of it. What else? Look at this. They're formed by what? One more time. They're not adjacent. All right. Adjacent and vertical are two different things. Clark. They're not perpendicular. Not necessarily. So they are congruent. So vertical angles are congruent. Now, what I was looking for, like Ann Bradley said, they are diagonal from each other. All right. But specifically, they share a vertex but they do not share a side. All right. So in other words, they are not formed by the same ray. They share a vertex, but that's it. All right. So typically, if we were looking at it, I say that they form kind of an X. So they share this vertex right here, but the vertical angles, they do not share a side. So this angle and this angle do not share a side. This angle and this angle do not share a side. So those are the vertical angles. All right. They're typically formed by two intersecting lines. So, can someone name me one pair of vertical angles? 2 and 3. All right. So with one of your colors, 2 and 3. That's one set of vertical angles. Someone else, name me another pair. 1 and 4. So with a different color, 1 and 4. Someone else. And Bradley. 5 and 8. All right. And there's one more. What is it? 6, 7. So the matching colors are my vertical angles. So if we were going to actually list it out, angle 1 and angle 4, angle 2, angle 3, angle 5, angle 8, angle 7, and angle 6. All right. Now, I left some space between the angles for a reason, because what did we already say that happens with vertical angles? What are they always to each other? What's their relationship? They're what? They're congruent. So with vertical angles, they are always congruent. So that means angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Angle 5 is congruent to angle 8. And angle 7 is congruent to angle 6. All right. So if I had said, what is the relationship between angle 1 and angle 4, you would tell me that they're vertical angles and that they're congruent. Any questions on that one? All right. The next one, alternate interior. Now, it's kind of in the name what it means. So, first off, when we say alternate, what is that typical? What word kind of rings in your mind when you hear the word alternate? Opposite. All right. What about interior? What do you think? Inside. So, this literally means opposite inside angles. So, what that means is that these are inside or within the parallel lines. In other words, they're between them. So, there's 4 angles on here that are inside the parallel lines. Can someone name me one of them? No one hasn't talked yet. 3 is. So 3 is one of my inside angles. All right. So any of the angles that are between the 2 parallel lines are the inside. So this area right here is the inside or the interior. Now, 1, 2, and 7, 8 are known as exterior angles. They're outside of the parallel lines. All right. Now, the transversal kind of dictates opposite or same side. So when we're talking about opposite, we're talking about opposite sides of the transversal. So inside the parallel lines, opposite sides of the transversal. So, can someone raise their hand and tell me one pair of alternate interior angles? 5 and 4 are. So 5 and 4 are both within the parallel lines and they're on opposite sides of the transversal. All right. What else? 3 and 6. Good. So 3 and 6. Within the parallel lines, opposite sides of the transversal. Now, what do you think my relationships to them are? Do you think they're congruent or supplementary? So I'll give you guys a hint. Let me ask you guys this. Why do you think 5 and 6 are not alternate interior? Well, they add the 180 for one thing, but also because even though they're on opposite sides of the transversal, they're not opposite from each other. They're not diagonal from each other. All right? So, if these two are not opposite alternate interior angles, because they're right next to each other on the line, and we know, because it's on a straight line, that these two angles are supplementary, that means alternate interior angles have to be congruent. All right? So whenever we talk about alternate interior angles, we're saying that they are congruent. So that means angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. So again, alternate interior means they're on opposite sides of the inside of the parallel lines, so opposite sides of the transversal, inside parallel lines, and they are also, make sure that those angles are also diagonal from each other. Just like what opposite angles means in any other part. All right. Any questions on alternate interior? All right. Let's look at alternate exterior. So, similar to alternate interior, except now the angles are where? On the outside of parallel lines. So, the only difference between alternate interior and exterior is that we're now looking at the outside of the parallel lines. So, angles 1, 2, 7, and 8. So, same concept applies. Opposite sides of the parallel lines, but they're just outside now. So, can anyone tell me one set of alternate exterior angles? 1 and 8 is. All right. They're both outside. They're both on opposite sides of the transversal, and they are diagonal from each other. And then there's one other set. What is it? 2 and 7. Now, just like with alternate interior angles, alternate exterior angles are also congruent. All right. So any theorem with parallel lines, if it starts with the word alternate, it's congruent. All right. That'll come in handy when we get to the next couple theorems. All right. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. All right, now I didn't bring this up, but you guys all know that this symbol denotes an angle, right? Okay, just making sure. All right. I just want to make sure I wasn't just drawing notation. You guys were like, what the heck is she drawing up there? What does that even mean? All right. Okay, any questions on any of the alternates? Alternate interior or exterior? All right. Now we have corresponding. All right. So when you hear the word corresponding, what do you think of? They're the same. All right. So they're similar. They're the same. All right. When I hear the word corresponding, at least in math, specifically when we're talking about these angles with parallel lines, I typically think about them as same spot on a different line. So in other words, if I look between the two parallel lines, so if I look strictly at line M, and I look at the angles formed by that. I look at line N, and I look at the angles formed by that. All right, the corresponding angles are the ones that appear to be in the same spot between the two lines. All right, so let's say angle 1. What do you think the corresponding angle to angle 1 is? 5. All right, between M and N, 1 and 5 will be the exact same spot, so those are corresponding. What about angle 3? What do you think? 7 is its corresponding angle. What about 2? 6. So that means that 4 and 8 are other corresponding. Now, if they're in the same spot, what do you think the relationship is? They're congruent. They're in the same spot, they're definitely congruent to each other because they're essentially the same angle. So corresponding angles are congruent. So angle 1 is congruent to angle 5. Angle 3 is congruent to angle 7. Angle 2 is congruent to angle 6. And angle 4 is congruent to angle 8. All right, so again, think about corresponding, they go together. So again, corresponding in math, it means they're in the same spot, but on a different plane of existence. So in this case, it's the same spot, different line. All right, same spot, different parallel line. All right, any questions on the congruent parts, the congruent theorems? All right, now let's get to the ones that are actually supplementary. All right, there's not many. There's only 2, actually. Well, technically 3. So, name and highlight the same side interior angles. Okay? So, we already know interior means inside. But when I say same side, that means literally they're on the same side of the transversal. All right? So, I'm talking about same side interior, same side literally means same side of the transversal. All right? So, what 4 angles are my interior angles first off? 3, 4, 5, 6. So my inside's right here. Now, someone name me one set of same side interior angles. 3 and 5. All right, those are same side interior. They're both within the inside of the parallel lines, and they're both on the same side of the transversal. All right. So by process of elimination, that means 4 and 6 are other sets. Now, we know already that the alternate interior are congruent. All right. What would the same side be? Supplementary. All right. So same side interior angles are always supplementary, meaning they add to 180. So these are always supplementary. So if I had to write it out, angle 3 plus angle 5 is equal to 180 degrees. Angle 4 plus angle 6 is equal to 180 degrees. They're supplementary. All right. Last one, same side exterior. Pretty much the same thing as same side interior, except instead of inside, they are outside. So outside is 1, 2, 7, 8. Those are my outside. So what do you think one set of same side exterior angles would be? 1, 7. Good. So 1, 7. So that means 2, 8 are my other set. And just like same side interior, these angles are supplementary. So if I listed it out, that means angle 1 plus angle 7 is equal to 180 degrees. Angle 2 plus angle 8 is equal to 180 degrees. Now, there's one last one that's not listed on here that I think should be brought up because you will see it. All right. It's one that's pretty obvious and it's like, oh, why would I not think of that? You'll be surprised how many don't think of that because it doesn't fit into like our already stated ones. So we're not going to sketch the line because again, it's pretty obvious, but above, if you have a little bit of space, let's talk linear pair or linear pairs. So from our notes previously, we know linear pairs are always what? They're supplementary, all right? So linear pairs, they're supplementary. Linear pairs are also, they're adjacent angles on the same line. So that means that they share a side, they share a vertex, and they're on the same line. All right? So just looking at the picture below, just for reference, someone name one set of linear pair angles in Revit. 1 and 2 are. All right, what else? 3 and 4 are. What else? 5, 6. What else? 7, 8. What else? And there's more. 1 and 3. 6 and 8. 6 and 8. 2 and 4. 5 and 7. All right. So any angles that are just like they're inside, outside, one's on the inside, one's on the outside, or they're both inside but they're next to each other, or they're both outside but they're next to each other, those are your linear pairs. All right. So I'm bringing it up just so you don't forget that they exist. Okay. So if you want to make a note, you can say 1 and 2, 1 and 3, 2 and 4, 3 and 4, 5 and 6, 5 and 7, 6 and 8, and 7 and 8 are all linear pairs, which means they all add to 180 degrees. All right. And again, we're not going to mark them just because, again, they're fairly obvious where they are. You guys should be able to identify supplementary angles by now. All right. At least like the standard generic on the same line supplementary angle. So, but I just, again, I wanted to bring it up because you will see it. All right. Any questions on that? Any questions on any of those theorems? All right. So just something to note here, they're basically just restating what the alternate interior, alternate exterior corresponding are. I would, since your papers are not colored, I would make sure that these are colored differently so you know which is which. All right. So again, it's just restating what we already talked about. Now, the great thing about knowing all of these different theorems is essentially we can only be given one angle of those parallel lines, and we can find every other angle in that set, which is what we're about to do. All right, so let's look at this first example. So, like I just said, if you know the measure of one of the 8 angles, you can find the measure of all of the others. Okay, so we only need to know what one angle measure is to figure out the rest. Because again, the relationship is either supplementary or congruent. All right. So they told us that angle 1 is equal to 120 degrees. So this angle is 120 degrees. All right. So let's go down the line and figure out what the other angle measures are. So angle 2, what's the relationship between angle 1 and angle 2? They're supplementary, but specifically what type of angles are they? They're a what pair? Linear pair. So angle 2 is a linear pair. They're also supplementary. So angle 2 has to be what? 60 degrees. Just do 180 minus 120. That's 60 degrees. Just make a note that they're a linear pair or LP. Angle 3, what's its relationship to angle 1? They're supplementary because they are what? They're a linear pair. So angle 3 also has to be what? 60. Now, if you didn't know that, you could have also figured it out because what's the relationship to angle 3 and angle 2? They're what? They're congruent or vertical angles. Specifically, vertical angles are congruent. All right. What about angle 4? What's its relationship to angle 1? They're vertical angles. That means they are congruent. So angle 4 has to be also 120 degrees. That's because they're vertical angles. What's the relationship between angle 1 and angle 5? They're congruent. But how do I know that they're congruent? What type of angles are they? They're corresponding. Same spot, different line. So that means that angle 5 has to be 120 degrees. And again, it's because they're corresponding. And guys, all of these that I'm writing out, it's in relation to angle 1. So when I say they're vertical, corresponding, or linear pair, I'm saying in relation to angle 1. All right? Angle 6. Is there a direct relationship between angle 1 and angle 6? No. Angle 1 is on the outside, angle 6 is on the inside. There's no direct relationship. However, I can find angle 6 based off of what angle? You could figure out based off of 2. You could figure it out based off of 4. You could figure it out based off of 3 or 5. Okay? So, I heard 2 first. So, what's the connection between angle 2 and angle 6? They're corresponding, which means they are congruent. Now, if I base it off of angle 5, would I get the same answer? Yes, because angle 5 and 6 are supplementary, so they have to add to 180. So either way, whichever one I picked, I'd still get an answer of 60. So that's the great thing about these guys. Once you get a couple kind of already figured out, you don't even have to rely on angle 1 much anymore. All right? Because I can now assume that, well, let's keep going off angle 1. Angle 1 and angle 7, what's the relationship? They're alternate exterior, which means they are, actually, they're not alternate exterior, they're exterior, yes, but they're not alternate, they're same side. On the same side of that transversal. So that means they are what? They equal 180 or they're supplementary. So 7 has to be what? 60. Could someone tell me another way I could have figured that out? They're vertical to 6, so they have to be congruent. All right. So this is also 60 degrees, and again, it's same side, exterior to angle 1. And then finally, what's the relationship to angle 1, angle 8? Those are the alternate exterior. Different sides of the transversal, both outside, they're alternate exterior, which means they're congruent. So angle 8 has to be 120. So guys, when it comes to these, it's also kind of a good check for yourself. Your vertical angle should be congruent. Your linear pair should be supplementary. Your alternate interiors should be congruent. Your same sides should be supplementary. All right? In other words, whenever you're doing this, you should get the same two angles every time. All right? Any questions on how to do that with this? All right? Okay, so take a minute, try this one on your own. So they're saying angle 1 is 72 degrees, so this angle is 72 degrees. All right, take a minute, try it on your own. Again, know what the orientation of those lines throw you. All right, thumbs up if you're ready. All right, check your answers. So you should have gotten either 72 degrees or 108, depending on their placement. How you guys feeling about that one? Pretty good? All right. Now, let's just do a quick vocab check, determining what the type is. All right. So, number 1, what type of angles do I have? We have corresponding. So, same side, different, not same side, same spot, different line. So, these are corresponding. What about for number 2? Someone else. What do I got? They're corresponding again. What about number 3? They're alternate interior. 4, still alternate interior. What about 5? They're corresponding again. and 6. Those are same side interior. So get pretty good at recognizing at least two angles, what their relationship is. All right. Again, if you know this vocabulary, it will really, really help you when we get into proofs. All right, because basically proofs are saying, okay, we can mathematically state that this and this are congruent or whatever, and we have to show why they are. All right. All right. So this next example or so is using algebra. All right. So let's just do a couple of these fairly quickly because we only got about 10 minutes, so we got to head downstairs. All right. So first off, what is the relationship between 1 and 2? They're same side interior, which means they are what to each other? They're supplementary. All right. Now, it says that the measure of angle 1 is equal to that expression, and the measure of angle 2 is equal to that expression. So I'm just going to mark it here just so I know. So 3x plus 16 is angle 1. X plus 12 is angle 2. So what is an algebraic expression or equation that I can write in order to solve for x? Say it one more time. You wouldn't set them equal to each other because they're not congruent. They are. So what do you think? Right. So we would add them together, set equal to 180. So that's why knowing those relationships are important. If they're congruent, you'll set them equal to each other. If they're supplementary, you'll add them together, set equal to 180. So we're going to do 3x plus 16 plus x plus 12 is equal to 180 degrees. All right. So if I combine like terms, 3x plus x is 4x, and then 16 plus 12 is 28, equals 180. Then two-step equations, y'all should be able to do those in your sleep. All right. So subtract 28. I get 4x is equal to what? 152. And then divide both sides by 4. So x will be equal to what? 38, I think, right, guys? Yeah. So 38. Now, that is not the angle measure. That's just what x is equal to. All right. So if I wanted to find the angle measures for angle 1 and 2, what do I need to do? Plug it back in for x. So I'm going to take this and plug it back in for x. So for angle 1, that's equal to 3 times 38 plus 16. And then for angle 2, that's equal to 38 plus 12. So I'm going to do angle 2 first because it's easier. 38 plus 12 is simply 50. So knowing what we know about angles 1 and 2, if I didn't want to have to do the calculation for it, what could I assume angle 1's equal to? 130, because they're what? Supplementary. So we could assume if I got 1, the other one should come to me fairly easy without even having to plug in for x. But the good way to check yourself is to make sure that that still equals 130, which it does. All right. So our angle measures are 130 and 50, respectively. All right. Any questions on that one? All right. Let's try one more. So look at this top equation. So it's labeled as number 5, but top left. All right. So we're given these two angles right here. So angle EFC. So they went from angle E to F to C. And angle GBD. So GBD. All right. Don't forget how we name angles. Essentially, you just start at whatever point they tell you to. You just connect dots. And that's right. All right. So what's the relationship between those two angles that are marked? They're alternate interior, which means they're what? They're congruent. So how do you think I'm going to solve for x first? Set them equal to each other because they're congruent. So I'm going to have 16x is equal to 4x plus 84. So I'm going to do this fairly quickly. So I'm going to subtract the 4x to both sides. That'll give me 12x is equal to 84. Divide by 12. X is equal to 7. So x is equal to 7. So how do I get my two angle measures? And I totally wrote where it wasn't supposed to go. So 16x is equal to 4x plus 84. Sorry, guys. So how do I get my two angle measures? Plug in for x. Now, they should be what to each other? They should be the same angle. So in reality, you really only need to plug into one of them to get the same number, but there's no harm in checking, all right, to make sure it's the same number. Because if it's not, you probably did something wrong in your initial calculation for x, all right? So 7 times 16, that is 112 degrees. So we just did 16 times 7. And then 4 times 7 is 28 plus 84. That's still 112 degrees. All right, we're going to put a pin in this for right now. I think we should have enough time when we come back to do one more example if need be. All right. If not, your homework for tonight will be pages 16 and 17. All right. So it's pretty much things that we've already covered. All right. So homework for tonight is pages 16 and 17. I will check that tomorrow. And again, if you didn't watch the video for 2.2 because the link was messed up, I'll double check that link today, but I believe the notes link should be correct. So was the video link in like the notes page? Was that the correct one? The unit notes one was the correct one? Yep. Okay. So the link in the unit notes is the correct one. Don't worry about the subwork one. So that one should work. If it still doesn't, shoot me an email, I'll fix it. All right. So what we're going to do is you're going to leave your stuff here. All right. But we are going to walk down together to the gym. We are going to enter through that first set of double doors by the library. I'm going to check you guys in, and then you are going to go get assigned a camera to go to take your picture. All right. So the photographer is going to ask you for your name. Make sure you're using your real first name and last name. All right. So if you go by something else, make sure you're telling them like your actual legal name. All right. And then whenever we finish, so if you finish, just go sit off to the side of the bleachers, but make sure you're together as a group because once we're all done, we'll head back to class. All right. So do not head back here without me. All right. All right. You guys ready? Let's go on our field trip.
It's all right. high school picture.